There are two ways to prepare methyl iodide. The first uses methanol with potassium iodide and 85% phosphoric acid. The second is the method we will use, which uses the slightly more exotic iodine and red phosphorus. First, measure out 60 ml of methanol. Then weigh out 75 grams of solid iodine. Iodine is very dense, and so this takes up less space than you would imagine. Finally, weigh out 15 grams of red phosphorus. The theory here is to use an excess of methanol and phosphorus in order to drive the reaction to completion. Add the methanol to a 250 ml flask equipped with a magnetic stir bar. Then add the iodine to the methanol in the flask. Some of the iodine will dissolve to form a dark brown solution, but not all of it will dissolve at this stage. Note the color at this stage. Set the flask in an ice bath with magnetic stirring in the bath to keep a flow of cool water over the bottom of the flask. I've also placed a thermometer in the flask to monitor the temperature. Once chilled down, slowly begin addition of the red phosphorus in small portions. Watch the temperature closely, and do not let it rise above 40 degrees at any point. As you add the phosphorus, you'll notice the color change to a dark red. You'll also start to see stirring commence in the flask, meaning that the solid iodine has dissolved. Set up for a simple distillation, turning the ice bath into a hot water bath by heating. Normally you would place a still head and thermometer on the flask, but in this case we want to distill off as much as we can, so I have opted to keep the setup simple. Aim to get the water temperature up to around 70 to 80 degrees C. Use ice-cold water running through your condenser, and also to keep the receiving flask cool. Soon, distillation will commence, and a pale yellow liquid condenses and collects in the receiving flask. The liquid is a mixture of methanol and methyl iodide, and the yellow color is produced by a very slight decomposition into iodine. The distillation takes a few hours, after which the distillation slows right down. When the time to product ratio no longer balances for you, stop heating and allow to cool. Here's our crude product. We collected around 70 milliliters of an amber-colored dense liquid. Place this into a separating funnel. Prepare a strong solution of sodium chloride, which also contains a few crystals of sodium thiosulfate, and add 20 milliliters of this to the separating funnel. Immediately you'll start to see the yellow color fading, and you'll notice an interesting behavior at the interface of the two layers, where the methanol in the organic layer migrates into the aqueous layer. Separate and reserve the bottom layer, return it to the separating funnel, and wash it again using 20 milliliters of water. Separate the bottom layer, and then add a small amount of anhydrous calcium chloride to dry the product. Filter the product into a clean, dry bottle using a glass funnel and a small amount of cotton wool. We collected 86.35 grams. This corresponds to a yield based on iodine of just over 81%. Methyl iodide is not shelf-stable long-term, but a small amount of copper wire added to the container will help remove any trace of iodine which is produced. Using an amber glass bottle such as this one will also help if you intend to store your product in good condition. Methyl iodide is fun for creating your favorite versatile methyl Grignard reagent, so stay tuned.